Hi, it's Mark from Top Local. We're here with Bernie Pawlik, Pawlik Automotive in Vancouver, Vancouver's best auto service experience, and 21-time winners of Best Auto Repair in Vancouver as voted by their customers. How are you doing today, Bernie?
Doing well.
So we're talking cars. We're talking about a 2015 Mazda 3 that was having electrical issues. What was happening with this Mazda?
So this vehicle came to the shop with a few concerns. One was the check engine light was on. Second, it felt like it lacked power at certain times, almost stalled. And the steering was doing something on my service advisor note said funky. So I had to call the owner and said, "Wait, what exactly happened?" Because something just feels wrong with the steering. So, and when I finally experienced the issue, yeah, funky was actually a good description for it. It was doing when I turned the steering wheel at certain times. So this is an electric power steering vehicle with electric power steering. I turned the vehicle at certain times. The steering wheel would like kick, like it would lose its power and it would just kick in my hand. It was like almost, almost an arm breaking kind of kick. So it was kind of a strange issue. And then there's a warning light on the dash for the steering. But this was an intermittent issue.
So what other testing did you do on the vehicle?
So first thing, of course, is hook up a diagnostic scan tool and scan the whole vehicle for trouble codes. And what we found was a code P0882, if I remember correctly, which is a transmission control module low voltage code. From there, of course, driving the vehicle was a key thing. And the other thing I often do is we have a database, a program that we access that has known vehicle faults. So that's usually the first place I go, okay, what could be causing this issue? So I go in there and no one else had ever had this problem, at least it wasn't in this database. So sometimes I go, oh, that's going to be interesting because we're kind of maybe not the first to ever see it, but it's the first, to kind of publish any issues around it. So, I looked at the diagnostic system, kind of tried to understand the circuit a little bit, understood the circuit and what was going on and figured, okay, this vehicle's not getting power to the transmission module for some reason. It's either a bad battery, charging system, or wiring, one of the above. So it's a matter of making tests. So next was to do a road test with the vehicle, go out and see what was actually happening to it. So as I mentioned, the steering was doing weird stuff, but then it would stop doing that. It would seem normal. So I went out, road tested it, hooked up the scan tool again, looked at the module voltage while we were driving and just to see what was going on with that. And I've got some pictures here I can show because it's got some neat stuff to share here. So there's our Mazda 3 2015. So it's only about a 4-year-old car, not too old at this point in time. This is a road test. So this is actually monitoring the power steering module. And you can see, for the most part, this is around 14, 15 volts, which is the normal electrical system. And at some point, all of a sudden, it starts dropping down, spikes way up, jumps all over the place, drops down to almost 0 volts. So none of this stuff should be happening. This graph should be basically staying kind of, around, 13 to 14 volts, somewhere in that range. That's where the power should be with the engine running. So clearly losing power in the system. And I noted at some point during the road test that the vehicle would also, when it came to a stop, the transmission seemed to be stuck in like 3rd gear. So I think it had gone into a limp mode. Now, what I was able to do is put the transmission back in park, then go back to drive, and then it would shift normally. But clearly, when this was happening, the transmission module was also losing power at the same time. So we were kind of onto it. And the other thing I didn't mention is when we do a full system code scan, a lot of modern vehicles, you can scan every module in the vehicle. It's really important to look at that. There's a number of low voltage codes in other modules. So that indicates kind of a major power fault in the vehicle. Then we did some further tests. Now visually, I thought to myself, okay, this car is, it's got the original battery. It's about 4 years old. That's kind of an average lifespan of a battery. If you just visually look at this battery, this is a disaster. There's stuff leaked out here. The case looks bulged. There's corrosion on this terminal, which this alone could cause a lack of power. So the next test was to actually test the battery, which we did. And there's the results of our battery tester. Sorry, it's a bit of a fuzzy picture, but 12-volt battery, bad battery. It's supposed to do 520 cold cranking amps. This thing measures 73 cold cranking amps. Although the voltage, interestingly enough, was good. And the other thing strange about this vehicle was that when you go to crank the engine over, it cranked the engine over just fine. So that's usually the first indicator that a battery's bad if it won't crank the engine over, but it would do that. Yeah, the other interesting thing we do is, of course, we do a full charging system test. So it had actually test the alternator. Voltage regulator failed, diodes failed. So probably we have suspected maybe the alternator was bad, but I figured better to replace the battery first and then test the system after. Just one other, this is the vehicle. This is the SkyActiv technology, which we'll talk about a little later, sort of a view of the engine compartment, the battery before replacement. And what else can we see? The coolant fill here, engine oil fill and dipstick there, air filter in this area, brake fluid, no power steering fluid because it's electric. So that makes things a little simpler.
And was there any other indication that the battery was bad?
There wasn't. As I was saying, it's interesting because I cranked the engine over several times because I right away suspected, okay, maybe it's got a bad battery. Cranked the engine over many times, and every time I cranked the engine over, it was just fine every time. So
what happened after you replaced the battery?
Well, so I replaced the battery, cleared the codes in the vehicle computer, went out and road tested it, and everything looked really awesome. Like that graph that I showed initially that had the big spikes, none of that was there. Just everything just stayed between 13, sort of low 13 to high 13 volt range, consistently solid the whole time, all the way through. Then retested the battery, retested the alternator. That code, it came back. The alternator was good. The voltage regulator good. Diode's good. So the battery itself was causing the alternator to malfunction.
So is that, in your experience, is it a better approach to replace the first known bad part and then retest rather than just, everything's bad, fix it all?
Absolutely. And this is why we have customers who, we tell them it's going to be this cost for testing and diagnosis. They go, I don't want to pay for that. Well, when we charge for it because it takes time. It takes time and proper testing to find the issues, and we take the time to look at that kind of thing, and it saves you money in the end. If you go to somewhere that's just going to go, we'll do that for free or very minimal charge, they're going to go, okay, you got these two bad components. They're likely going to say you got these two bad components, change them both, and the client's bill would have been at least $500 more had they not done that. Now, I say we take that two-tiered approach. Let's test this first, see how it works. If there's a savings to do both at the same time, then it's probably worth doing. But there's no savings; these are completely separate components. It takes very little. It takes very little to test, put the battery in, test it, and then just redo the test again and see how it is. Very little extra effort compared to So that's how we do things here.
Better for the customer and easier for you guys in the long run.
Well, exactly, and and you can sleep at night better knowing that we did the right thing, and it's always nice to know we give the customer the best value.
And how long should a person expect a battery to last? Car battery.
Usually, the average lifespan on a battery is usually 5 years. Some will last longer, some will not last as long. This one's made it for about 4. So yeah, 5 years is about considered average. I find most cars, probably 4 years. 4 to 5.
Here's another question. So we're talking about 12-volt starter batteries, which are very different from as we move into an electric future. Batteries are changing incredibly.
Absolutely.
It's a lead acid battery. So those dirty terminals from never being cleaned and looked after, maintained properly, is that perhaps led to this battery failing prematurely, slightly?
I don't think so. Actually, I think those corroded terminals actually indicate to me more like the battery's actually bad. Because what'll happen is that when the battery gets bad and old, it'll start gassing more, and it'll like there's sulfuric acid in the gas, and liquids will come out, and that'll cause the corrosion worse. So I would say it's actually the other way around. The actual battery itself will cause that. You have a good battery and a good charging system. It's not overcharging. Generally, terminals don't get corroded. It normally happens from something going bad. And of course, we clean the terminals as part of the service. It's critical.
And that's probably thinking back to old batteries when you could fill up with the acid and all that sort of stuff. These are all completely sealed batteries today. Is this more of an issue or less of an issue?
Well, actually, this battery is actually not a sealed battery. You can actually pop it open and add water to it. To be honest, I didn't do that, and we don't normally ever do that. You really don't need to do that in any regular type of battery. The only type of battery that you would ever want to service like that nowadays is a deep cycle battery. But this battery is actually still, it's kind of like old technology. You can actually pop the cap open and add. You only add water to it, by the way, because only the water will evaporate out of the battery. The sulfuric acid will never actually evaporate. It all stays in the battery. So So you can add water, but you got to be careful what kind of water you add too. You don't want to put any highly mineralized water in because that can create problems. But yeah, again, it's like with the age of this battery, even if the water was low in one cell and you topped it up, chances are you'd still have problems, you know. And this battery, again, you know, probably had some kind of internal short circuit or something that was causing it to intermittently malfunction like it did, you know, allowed the car to start, and yet, you know, it failed the load test and would intermittently go bad. So that's kind of the issue. You know, with batteries nowadays too, I mean, even cars, you know, non-electric cars, there's more and more electrical components. So batteries are more critical than ever, you know, like, especially like electric power steering in this car. It relies on a good, strong battery. So, you know, and a good charging system. So even a full internal combustion engine vehicle nowadays still, you know, having a good battery is a critical thing.
And you mentioned the automatic transmission had a sensor that was not getting enough power. Is that part of the shifting system using
Exactly.
electricity?
Yeah. So the code that we actually had stored in the vehicle computer, the main one was for a transmission control module, like insufficient voltage. So again, like when the voltage was dropping down from the battery, say to the steering that I monitored, the same thing was happening to the transmission module, and the same would happen to the engine module as well, I would think. So I didn't monitor that circuit. There was no code for that, but clearly that's why the vehicle was driving strangely and the transmission was shifting funny.
And sticking in third gear when you stopped.
Yeah, yeah. And you know, it's interesting how some of these basic electrical, sometimes, you know, when you're testing and repairing cars, you can think, oh, it's going to be some elaborate problem, and often the basic things are the problem, like the battery. We had a Chrysler vehicle this week that had a whole bunch of transmission trouble codes. When we did some research on it, found that often a faulty alternator caused these. Tested the battery and charging system, sure enough, found the alternator had blown diodes, and that'll cause like huge voltage spikes in the system, and that'll cause the sensors to, the computer can't quite read the sensors properly because it's getting, you know, strange voltage signals. So replace the alternator, the car was fixed. So a lot of times, the more basic electrical things, they have to be in good shape for everything to work properly.
And the diodes in the alternator are part of what changes that AC current into DC to charge and operate the systems, the CAN bus system in the car.
Exactly. And, you know, with a blown diodes, you know, what'll happen is instead of getting a nice clean DC signal, you'll get a huge spike of AC voltage that leaks past. So you get, you know, what's supposed to be like kind of a fairly flat 14 volts will all of a sudden will often jump up to like 16, and, you know, it'll keep spiking up and down, and that just causes real strange erratic things. I've seen numerous issues with bad alternators. So we're kind of drifting off the battery, but the battery and alternator, they really do work hand in hand. And a bad battery can wreck an alternator. So it wouldn't have been surprising on this Mazda that it would have needed the alternator. It just didn't in this case. Or a bad alternator can also wreck a battery. So, you know, either way, it's good. You know, it's good to make sure they're both healthy.
So this vehicle, as you mentioned, has Batman's SkyActiv technology. Does it have a bat signal?
No, it doesn't, but it's SkyActiv. So
what is SkyActiv?
Well, it's a name, you know, like Honda Eco Dreams and stuff, but it's a technology that Mazda's put together for you know, the best fuel economy, for the best horsepower, for the best fuel mileage, you know, which is important nowadays. You know, every manufacturer's trying to get the most they can out of their engines. So, you know, some of the features, it's got much higher compression. It's in North America, it's like 13-to-1 compression, which is really high for you know, an average engine. I mean, it used to be like 10-to-1 was really high, but 13 is like, that's like race car high. And apparently, you know, in other markets, the engine's actually 14-to-1 compression, which is like unbelievably high. So they're able to do this through the way they do the valving of the engine. It has direct fuel injections as opposed to the standard port injection that we've used for many years. A port injection injects the fuel into the intake manifold right above the intake valve, whereas direct injection is like a diesel. It injects it directly into the cylinder. And most engines nowadays have this technology, and it gets, you know, it's way more precise combustion, and it allows things, you know, having these high compression ratio engines. So high compression ratio engines more efficient, but there's a lot of problems like engine knock and ping. So they've had to do a lot of work around that to make sure it doesn't knock and ping, especially on regular fuel. It's a pretty neat it's a pretty neat accomplishment.
So if you're looking for service for your Mazda in Vancouver, the guys to see are Pawlik Automotive. You can reach them at 604-327-7112 to book your appointment. You have to call and book ahead because they're always busy. Very popular guys. Best auto repair in Vancouver. Or check out the website, pawlikautomotive.com. YouTube channel, Pawlik Auto Repair. Hundreds, literally over 350 videos and blog posts on both of those places about all makes and models and types of repairs. If you like reading about cars, there's tons, and listening about cars, or two goofy old guys talking about cars. It's on there. And of course, thank you so much for listening to the podcast. We appreciate it. If you feel motivated, give us a like. 5 stars is always nice. Thanks, Bernie.
Thanks, Mark. Thanks for watching. Thanks for listening. We totally appreciate it.